To the Czech Technical University Faculty of Informational Technology, I would like to present our contribution to the Kubernetes Community Days conference, which is how we are teaching DevOps at this school. So we'll go over basics. What is DevOps? Or let's define what is DevOps in our view. Where it applies in the software development lifecycle, what professions are related to it, and what kind of professions would we like to bring up here at our university. And then we'll go over how we designed the course and what are the alternatives at different schools. So our definition of DevOps looks like this. It is a merge of three disciplines, let's say, which are firstly the development and the development best practices such as code versioning, work tracking, and so on. Then there is the circle QA, that means software testing and general quality assurance. And the last is IT operations. All these circles are intertwined, meaning that the developers need to learn the pipelines from the testers and should also take some care of how their application fares in production. Testers, of course, need to use pipelines, need to know how the thing is deployed, and the operators take practices from the developers, such as scripts, infrastructure as code, with versioning reviews, and so on. If we unravel these circles into a line, we have this kind of diagram, and there are different buzzwords underneath the timeline of the software development lifecycle. What it should show is that DevOps should cover the whole software development lifecycle. Automation techniques. The tenets of DevOps are that we are trying to automate basically everything. We want the processes to be repeatable scripts, to be treated as code, and that should bring us some benefits. Otherwise, we wouldn't be doing it, such as we are able to do repeatable deployments. We can have identical environments for development, testing, production, and the whole thing should reduce the time between writing code and deploying to production. Because in practice, often there is a big time lag between what the developers are doing and what version of code is actually running. So when there is a bug that shows up in production, the developers would say, yeah, we already had it. This was fixed 2 months ago. So, or worse, they don't know what bug it is because they already forgotten. So DevOps is about shortening the time between an idea and its realization. What professions are related to DevOps? Because DevOps is a philosophy that talks about collaboration. There was a misconception when this buzzword first came to be. The managers thought that DevOps means, yeah, the developers will do the operations, we don't need the administrators anymore. Unfortunately, that was not true and is even less true nowadays when the DevOps field has grown into a very wide breadth of technologies. So we also need multiple professions to take care of different parts of the software development lifecycle. So in the planning phase, we would have from agile development, the Scrum Master and product owner. Then in code phase, there is the developer, of course. And then comes the usual DevOps guy. I would specify it more clearly as the build and release engineer. So if you're hiring a DevOps guy, you most likely need the build and release engineer who is active in the build, test, release phase. He's building the pipelines, making sure it passes, helping the testers and developers write their scripts. Then there is the tester, and right next to the tester sits the DevSecOps engineer. That's the guy who implements the shift left strategy and shifts security from the operation phase left in the timeline into the testing, so that bugs are encountered before the application is even running. SRE, System Reliability Engineer, or maybe I learned today that maybe it is the platform engineer, maybe this buzzword got renamed. That guy is most active in the deploy and operate phase, and also takes care of the cloud platform itself. So there would be another line joining here before the deploy phase, where the SRE guy needs to provision the cloud resources so that this software deployment pipeline can even run. And the FinOps is someone who monitors the cloud spend in the operations and gives feedback back to the planning so that the application is built with costs in mind. So this is a wide range of professions, and our school basically got the feedback that our people who are leaving the school are not fit for practice because they don't even know what code versioning is, much less all this spectrum of new technologies. So that's why we designed a new study program a few years back, I think 2021, a new version of the informatics study program with this in mind. So this is how the program is structured. We've got some prerequisites that are common for all specializations in this program, such as Unix-like operating systems, because you cannot do any DevOps before you know the Linux command line. Sorry, but that's the reality. Then we have the cryptic subject development, software development technologies with less cryptic abbreviation BI-Git. So that's where we implemented the ask that our leavers of the school need to know code versioning and branching and so on. And after that, in the third semester comes our subject, Introduction to DevOps, where we continue with that, teach them how to track work, how to build a pipeline with building and testing. Also, some DevSecOps comes into play. And in the second part, we teach them how to package the application into containers and deploy it either on virtual machines or the more cloud-native way on Kubernetes. Also, there is some infrastructure as code and monitoring at the end. We struggled a bit with what kind of program to teach this on, because we've got 3 specializations who have this subject as compulsory, and they do not have the same programming language in the prerequisites. So programming and algorithmics, that's C and C++. Then the most numerous are software engineers who have Java, and web engineers have either PHP or Python. So we standardized on Java, which the majority has, so that's our sample application. After Introduction to DevOps come other subjects in our specializations, which can continue with this line. And I know that software engineers in their projects are heavily using what they learned in our Intro to DevOps. And yesterday I spoke with the teacher of administration of database and web servers, and he also promised to bring in some Ansible into his teaching at least. So, as you have seen, we have multiple specializations, and there were different requirements. From the software engineering, they wanted mostly the first part of the pipeline, building, testing, static code analysis. Also teach what different environments mean, and they wanted some GitOps inside. The more administration-heavy specialization needed the second part of the pipeline, such as using clouds, infrastructure as a service and platform as a service, how to prepare the cloud environment, that's the work of the SRE engineer, and do a continuous deployment pipeline so that an artifact gets immediately deployed. Unfortunately, nobody had enough knowledge to teach this whole spectrum, so we joined forces of two departments, Department of Software Engineering and Department of Computer Systems, plus some experts from practice, and we created a compulsory bachelor's subject. It is practical, more practical, because 60% of points are from practical exercises and 40 from the exam. Before us, there were subjects mostly in the master's phase of the study, where there were quite little numbers of students, where a lot of gave up because of difficulty of the subject. However, the difficulty was because there were higher expectations. In the master's phase, you can expect somebody to become DevOps architect, to design pipelines, take case study and design something accordingly. While in the bachelor's phase, you need to lower the expectations. We strive to teach the students to use the technology and apply the principles to a slightly different task, but still basically the same task. However, because we introduced the DevOps earlier than was in this previous literature, we can follow up in other subjects and repeat. And this way, most of the students from our specializations, software and web engineering and computer systems, will have this knowledge. What technologies we used? We are heavily focused on GitLab, which is our platform for code versioning, work planning, code reviews, CI. That's all. Our sample application is in Java, as I said. We are testing using JUnit and Mockito, plus some demo of testing user interface in Selenium. And we have SonarQube for security analysis. The second part of the subject uses OpenStack and Ansible. We teach how to work with SSH keys because that's the first subject where they meet them, besides access to Git. We have container tools, Podman and Builda. GitLab also serves as a container registry. And in the role of platform as a service, we have OpenShift, which is a distribution of Kubernetes. Terraform is an infrastructure as code tool, and Prometheus is for monitoring. And at the end, a few pictures so that it is a bit more colorful. This is the pipeline at the end of the subject. Basically looks like the theory. This is the result of our students from this semester, actually. It was more enrolled students than last year, 349. Out of the 291 finished English version, and the remote version of the study had a little less success rate. However, in the remote version, you can see a lot of A's, meaning people who already had this experience, probably. And this slide is what grades did the student give us. That is the student survey. So looks like average 1.8. Yeah, still quite good. So, and as I mentioned, we had some expert in practice helping us with the subject, both with teaching and providing our sample application. And those came from a sponsor company. And my colleague Jakub Novák will tell you something.
No. Okay. Thank you. Well, I'm not a software engineer. I'm not a programmer. Well, I was before, but not yet. And I see that every one of you here is using some very professional ways how to improve their either coding abilities or software engineers. I had to find out what does the K8S means, for example, before this presentation. I'm very proud of it that I already know it. I know that you know it, of course. But not only me, it's the whole faculty that we have here. That's actually the same place we are here right now. I wanted to tell you more about some numbers. I found 2 of them. Well, I know from the head that we have around 2,000 students here, and all of those are those experts that Tomáš was telling us that we that know everything about the whole programming cycle, whole development cycle. But he mentioned sort of that those students are not well. They're more in theory than in praxis, but not only. We have like 20 laboratories at our faculty and 13 research groups that have this impact on them to find out something out of praxis. We don't want them just to know the theory. We need them to be able to, after finishing and completing their studies, find out some good job. Maybe with you, maybe from one of your companies, or maybe if they will be very good, then we want to keep them with us. But where to? Like those 20 labs or 13 research groups, those keywords that you can see over there just mixes something that is actually right now well known. Those buzzwords are embedded security, data science, ethical hacking, image processing, programming research. If you add a word laboratory at the end of each of those words, you'll get the laboratory that we have at our faculty. So that's really the place where those students can get something out of practice. Like real praxis. We have projects with commercial companies. We do artificial intelligence. We do UX testing and everything that's that has something in common with these buzzwords. Those guys, I mean students, that they are really good. We'd like to keep them in our labs, make them something more, and then let them to your word to be for you to be much better than they could have been without the practice in our lab. Maybe for you is one of those labs is much better for you than the others, and I wanted to mention the programming language, programming research laboratory. Those guys are our international team with the Professor Kirsch from Austria, and they were really successful at getting some huge projects like Big Code. Or evolving language ecosystems. All of those are public grants that you can look into, and all of those produced a really huge number of students that are now not only theoretically able to think about development, but doing them in practice in this laboratory. Well, if they're a company and you know that we finally have some students that that are able to work somewhere, so you can maybe look for students, or you can look for professors at our faculty. Those are our only commodities that we can offer to you, if you're a company, of course. we have these really great students. Two of those are over there. And if you want to get in touch with those students, not only to come to this conference, but join us with the sponsoring program, or if you want something more than those well-studied guys, you need more studied guys that are our professors. Like, for example, this Professor Pavel Surinek, who is a great guy at robotics, with his robotic agents laboratory over here. If you want to get more out of those, and I mean professors, you can ask us to become our partner, and maybe to have all of those previous big-scaled projects that we get from publicly funded grants together with us. Or our biggest commodity here is something that looks like almost the same thing that's happening right now outside these doors. And it's our job fair that's almost similar at the very same place that we are here right now, but it's crowded with students. I was there. I was there in the lobby. There are many of you guys, but it's not crowded. Imagine yourself like 10 times. Imagine yourself a little bit younger, and then you have our job fair that's happening over there. We have like over 60 companies that are really wanting to present themselves to those students. The students' crowds are just flowing through those space, and they're getting well. Students want to see the real companies that can offer them something in practice other than our laboratories. So if you're interested in there, maybe we can meet again at our job fair that will be happening at the end of October. And maybe with some of you we'll be having our contract signed. We'll see. If you want to meet us, we can meet in person or we can meet online with the whole Department of Cooperation with Industry. Thank you. Perfect. Please tell me there is a company here somewhere. Are you a company? 1, 2, 3. Okay, we need more companies. And the others of you are students? Yeah, or employees. Oh, cool. We don't want to promote our study programs. We know that you're after your studies maybe. Or if you want to, you can attend our postgraduate program. We call it an industrial PhD. You can be funded from your companies or other companies. We can find you some that's interested in the research. And you can get your PhD even in your 30s or 40s, 50s. Okay. Okay. Fine. If you don't have questions, well, thank you for your attention. It was a really pleasure to tell you something more than welcome at our faculty, and maybe we will see each other somewhere with the contacts that we posted before. Thank you.